Hey kiddos, here's your Spiral Review video for feedback for Spiral 12. We're going to start off with factoring graphing polynomials. For question 8, the first thing I notice is we get 4 pieces here. And if I see 4 pieces, I want to try grouping this automatically for us. The first 2, I can take an x squared out, and that would leave me with an x and a plus 4. The second 2, I can take a minus 4 out, and that's going to leave me with an x and a plus 4. Okay, that gives me x squared minus 4 and x plus 4 as my factors. If we've got x squared minus 4 equals 0, that means we got x squared is equal to 4, and if I take the square root, x equals 2. Whenever you take the square root of your own problem, you got to make sure you include the negative value as well. That's one of the big places that we lost people on this particular part of the spiral, and I wouldn't be surprised if you saw this again on your spiral coming up. So you've got x plus 4 equals 0. That one's a little bit more straightforward. That gives us x equals negative 4. For the y-intercept, that's what this question is over here. It's always just going to be this last number. A number of you put a big question mark there, and I want to make sure that we know this is just going to be negative 16 here. All right, sketching a graph. Let's put these points on so we get negative 16. I'm going to have 2. I'm going to have negative 2 and negative 4. I also know that at the beginning we've got a positive number, so from 2 our graph's going to go up and to the right. Hitting all these other points with a nice smooth graph, we get an N-shaped graph. No bounces or anything, and as x approaches negative infinity, that means left. I take a look at my graph, and on the left side we're going down, so this should be negative infinity also. On the right side, that's when we approach x to positive infinity, we're going up, so this is going to be positive infinity as well. For the bottom part, we're looking at a graph with a polynomial equation factored form. The first thing that I saw a lot of was not knowing how to make these factors. For each piece, we're going to do the opposite of the 0, so x plus 3, x plus 2, and x minus 1. I also notice that there's a bounce at x equals 1. I'm going to write bounce under that factor, and that means that that piece is going to be squared. Anytime that we have a bounce, that will always be the case. The last thing I need to do is to figure out what number goes out in front. And to do that, I'm going to use the y-intercept and write 12 is equal to a times 0 plus 3 is 3, 0 plus 2 is 2, and 0 minus 1 is 1 squared. That would give me a times 6, which means that a is 2. My final answer would be the same thing, except with the 2 out in front. Next up, we got polynomial long division. And the first thing we're going to do is do some dividing. I've got x plus 5 as my divisor. And I'm looking for what I can multiply x by to get to 2x cubed. That's going to be 2x squared. When I multiply down, we get 2x cubed and plus 10x. Squared, and then I got to subtract. A lot of people did okay getting to this first part, but then not knowing what to do next. So we're getting somewhere with this, but we got a lot to go. We subtract, we get 0, and then we get 2x squared. Bring down my plus 7x, and then I do the same thing. To get from x to 2x squared is plus 2x. I'm going to multiply that down, and I get 2x squared plus 10x. When I subtract, we get 0 and minus 3x, and finally bring down the plus 16. And I repeat the process for a third time. To get from x to minus 3x is going to be minus 3. I'm going to multiply that down. We get minus 3x and minus 15. And when we go and subtract, we get 0, and we get 31 because we're minusing a minus to get there. This is the second place I saw a lot of subtraction errors, and I mentioned that that's where we're probably going to have the biggest issues in terms of what to expect for these problems. But if you got most of the way there, you're in really good shape. And when we do that, we get a remainder of 31, and we're going to put that over x plus 5. Okay. Second part of this is to use synthetic division to check your work. The first thing that you need to do is to set up synthetic division. So if we're dividing by x plus 5, that's going to be minus 5 on the outside. Let me put the coefficients. We're not missing any power, so we're good to go. We got 2, 12, 7, and 16. And I'm going to bring down the first one. And then I'm going to multiply. Negative 5 times 2 is negative 10. 12 minus 10 is going to be 2. Negative 5 times 2 is going to be negative 10. 7 minus 10 is going to be minus 3. And negative 5 times minus 3 would be 15. 16 plus 15 is going to be 31. We know that's our remainder. And if I wrote that as 31 over x plus 5, going backwards, we then have minus 3 as the number. We'd have 2 with an x, and we have a 2x squared. Those are the same things that we got when we did the problem using long division, so we're in good shape. Is x plus 5 a factor? The answer to this is no, because the remainder was 31. When we have a remainder, it's not a factor. Is x equals negative 5 a 0? This idea comes from when you plug in negative 5, kind of like what we did here. Whatever the remainder is would be the answer to that value. So if I found, I don't know, plugging x equals negative 5 in, we'd end up with 2 times negative 5 squared plus 2 times negative 5, and then minus 3. I like that I'm using the dividing part, which is totally not what I was trying to do. Although those numbers, there we go. So it'd be 2 times negative 5 cubed, that's what I'm trying to do, plus 12 times negative 5 squared, plus 7 times negative 5, and then plus 16. When you do that, you're going to get 31 as the answer. And that will always be the remainder. So you could also say, no, remainder equals 31, and that would work for that as well. These are really the same question phrased in two different ways.